Okay, now let's move on and do uh, the 7C. If you look at the 7C, this is what we have here. 7C is this one. It says use your graph to solve negative, x minus 3. So, these are some of the things you need to understand. They're going to give you the graph. You're going to generate the graph, and they're going to find a way to trick you to solve equations using your graph. So you need to kind of be a little intuitive. So, for instance, they're saying that let's do C I. They want you to do x minus 3 x plus 1 is equal to 2. You know your equation, the y that you have drawn has actually half to it. So you always want to generate your equation to resemble exactly what you have in your equation. So what I'll do is, for instance, if I divide this out by 2, let's multiply by half and multiply this one by half, then I'll get half x minus 3 x plus 1 is equal to, this will cancel this one, equal to 1. And you notice that this is equal to um, this is equal to y, so therefore I can say y is equal to 1. That is what they want me to solve. Y is equal to 1 means find the equation such that, solve for y is equal to 1. And for y is equal to 1, what you do is you come back to your graph, and this is my graph here. As you can tell, this is my graph here. So when y is equal to 1, I can come back here and draw a straight line. I can come back and draw a straight line for this. Let's come back here. Let's look at my tools. If I want to draw a straight line, I'll draw a straight line for when y is equal to 1, which is positive 1. This is this line here. I can draw this line here. Just this line here. This is the line y is equal to 1 because it's just passing through 1. When y is equal to 1, look, it means this at this point here. So we can tell straight away that it's going to meet this point at this point right here, right here. You can see this little point here, and also this little point here. So these points, and always when they want to solve, they want to find uh, the value where it meets, the x-axis. So as you can tell, when y is equal to um, uh, y is equal to 1, it will drop down to somewhere here. So you're going to have your x, the solution said to be x such that x is equal to, and if I drop this is almost about, this is negative 1, it's about negative 1.4. all right, negative 1.4, negative 1.4 comma, and when I come to 1.4, this is this line here, right? And then this one here is also, this is about 3, actually it's about 3.5. It casts it at about 3.5. So, and also 3.5. So that is what will be the solution for the CI. Now let's take a look at the other part. I think let's move this one here. But the other part, the B, uh, the II is this. Let's take a look at the II. The II, the CII, they want us to find x minus 3 x plus 1 is equal to negative x. And you see, there's a reason why they ask you to draw the second line. You remember the second line was y is equal to negative 1 over 2 x. And so, and similar to what we just did, if I divide this out by 2 and divide this out by 2, then I'll get 1 over 2 x minus 3 x plus 1 is equal to minus 1 over 2 x. You see what is happening? It means if I call as we drew in our graph, remember when we did our graph here, we said this equation here is y1, the straight line is y1, so this is equal to y1, and this we say is equal to y2. So we are looking at the equation, let's erase this. We're looking at the equation y2 is equal to y1. Y is equal to y1 is these are the position where the two curves meet. You see that the position where the two curves meet. So let's look at that. So where do they meet? Maybe we can change the color here. Where do the two equations meet? Okay, let's come back here and see. So the two equations meet at this point. You see here, they meet at this point here, right there, and also this point here, right there. All right. So now what do you do? So now you need to find the corresponding values of uh, they occur at y2 is equal to 1 1 mean they occur at two different, x1 and x1 and y1, and then x2 and y2. So they meet at the point when x is equal to, here is more or less like negative 1 point. This maybe let's increase the scale a bit so we can see it clearly. If you are using your real graph, I think you see it clearly. Let me zoom this a bit, zoom a little bit. Yeah, I'm gonna zoom this one here a bit so you can see it clearly. Here on this here, you see this is, they meet at the point, this is the red and the green line, they meet at this point right here, and that will be negative 1.2. So in essence they meet at a point. I'm gonna come here. So the first solution set here will be this. They meet at these 2 points. So point 1, p1 is equal to x is equal to negative 1.2, and then the corresponding y, the y was also is about maybe 0.5, right? If you can see that clearly. And then p2 is equal to and that's with this point here. If you move down somewhere here, this is where the point they meet again is. So this point to be 2, it's about 2.4, x equal to 2.4 comma, and y is equal to, I think this is negative 1, so this is negative 1.2 also. See that right here, this is negative 1.2, so this is negative 1.2. All right, so these are the solutions set for the problem. All right, I hope you understand what we are doing, and I'll see you in the next video.